All right, so like I said, we've already finished up the formula writing piece. We learned how to write the formulas for ionic compounds given the name. We've learned to write the formulas for covalent compounds given the name. We've learned to write the formulas for acids given the name. What's left? Give the formula and you write the name. That's all we have left, is going backwards, okay? It really doesn't matter which one I teach first, because by learning one way, you kind of already know how the names work out, because you've been reading the names for like the last week and a half. You know what I'm saying? So this isn't going to take much on your part, I think. There's just a couple of, I guess, details I want to point out. You know what? There's really nothing on here that's going to be helpful. It looks like we're on basically page 6. Oh no, we're kind of done, aren't we? I don't even know if there's anything in here we need. So on page 7, you've got this little idea where it says try. And then the next thing I believe says something about hydrates, yes? Okay, well, we've already covered the hydrate piece. If you see the word hydrate, what does that mean? There's water molecules associated with it. And you're going to see a prefix indicating how many water molecules. So, for example, or I can put, what do I want to say? What would be a good one? Okay, let's go this route first, because this is what we just most recently got done doing, is taking a name and going to the formula. Okay, so how would we write the formula for this compound? It looks pretty intimidating, doesn't it? But you guys know all the pieces. What's the symbol? Yeah, Fe with a 2+ charge. What's ammonium? 4 with a 1+, very good, charge. SO4, or sulfate, is SO4 with a 2- charge. Okay, so there's all the pieces. Now, what's the sum of all those charges have to be? 0. Okay, how are we going to get there? This one's not easy. It's not hard, but it's not that easy either. Go ahead. 2 ammoniums, because that will then give me 4 positive charges. So now I need 4 negative charges. So 2 sulfates. Would you agree? Okay, so there you go. So it's FeNH4 taken twice, SO4 taken twice. But now I have to deal with this. What does that tell us? You're close. What'd you say? No. What's the prefix? 6. 6 what? 6 waters. There you go. So that would be how you would write the formula for that. Okay, so anytime you see the word hydrate, 1 is going to have a prefix with it telling you how many, and then you just write water. And the dot, as we said earlier, does not mean multiply. It just means that there's 6 water molecules associated with every one of these. Okay? Now, going in this direction, clearly we're going to go to the name first, right? What type of compound is it? Is it ionic or covalent? It's ionic because there's a metal, which means we don't have to worry about prefixes. So what is Mg? Magnesium. What's SO4? Sulfate. Is this a hydrated compound? Sure. How many? 7. What's the prefix for 7? What's that?
Septa.
Close. Hepta. There you go. Magnesium sulfate heptahydrate. The only thing you're going to have to be careful with in general is if you see this, we'll start off with this one. And if I do something like this, okay. Let's start with this one. Is this an ionic compound? Yeah, iron's a metal, so we don't have to worry about prefixes. Okay. However, iron is a transition metal, so what do we have to be concerned with? What's that? Yeah, which iron is it? Okay. We know it's iron, we just don't know which iron it is. Well, what's the O? Oxide. It's oxide. Does anyone know the charge on oxygen ion or the oxide ion? It's 2 minus. But I've got 3 of them. So what's my total negative charge? 6. So I need 6 positive charges. It has to be iron 3. Okay? Or right? Okay. But there's a problem with doing the uncross thing. Remember we talked about the crossover? Okay, and many of you used that idea, I think, didn't you? But I kept emphasizing look at the total amount of charge to help get there because of the problem that we're going to run into here. Is lead one of the metals that can form more than one charge? Yeah, remember I said tin and lead were the 2 representative elements that can form more than one charge. So which lead is this? Okay, many of you are leaning towards lead 2 right now, correct? But it has to be lead 4 because remember oxide is 2 minus. I have 2 of them, so that's 4 negative charges. Therefore, the lead has to be plus 4. Okay, so be careful on those. And then down here, ionic or covalent? It's covalent because there isn't a metal, so now we have to use the prefixes, right? So the name of this would be chlorine trifluoride. There you go. All I tried to do there was show you all the little things that will have historically caused students a little trouble at the beginning. Okay, ones where we have transition metals that can form more than one charge. How do you figure out which one it is? Be careful with how you do some of them then, because it can be a little tricky. And then just ask yourself, is it a metal or a non-metal or a covalent compound? Okay. I'm going to give you practice on this tomorrow. I've got it here, but I'm not going to have time to get it in your hands. Know your polyatomic ions clearly. Know how to find the charge of ions based on their position on the periodic table. And recognize whether it's ionic or covalent. If you can do those things, you'll be good.